Good afternoon. Good afternoon, everybody. And thank you for coming to celebrate the International Day of Women and Girls in Science. My name is Dr. Marina Leondiadou, and I am very excited today to have Professor Dame Jocelyn Bell Burnell here today to talk about women around the world working in astronomy and astrophysics. Just before we get going, I would like to mention a few points of administration. First, I hope everyone signed already and registered for this event. There's also some sign-in sheets at the reception. If not, please do so at the end of today's talk. It's helpful for us to understand the attendance. Secondly, can everyone please keep their questions to the end of today's talk? So keep a note of everything you would like to ask. At the end of the talks, there will be lunch set up by the entrance. Toilets are all located outside towards the box office, and we are not expecting any fire alarm test today, so if alarm goes off, please exit at the front of the building. Before our guest speaker, I would like to hand over to Professor Nick Beach, our Vice Chancellor, to say a few words of welcome.
Thank you very much. So I am utterly delighted to be here today, and Jocelyn, it is wonderful to have you with us. Others will give a perhaps slightly more formal introduction, but I wanted to just say something quite personal, if that's okay. Well, I'm going to say it anyway. So Jocelyn has got this incredible list of achievements throughout her career, and I will slightly embarrass her by talking about her discovery of pulsars, being president of the Royal Astronomical Society, being president of the Institute of Physics, being the first woman president of the Royal Society of Edinburgh, and Chancellor of the University of Dundee. What a fantastic role that is for all of those of us who were there at the time. These are really important things that she has done. But there's something else that I just wanted to draw attention to, and I'm sure that Jocelyn will talk about this. And that's her role with a group of other women researchers founding Athena Swan. And for all of us, not just in UK academia, but now actually around the world, this was a crucial change. And the argument behind this group was, in fact, at the time, women were massively underrepresented in STEM subjects. And we needed a way of corralling those with goodwill and universities and other forms of institute to start seriously shifting their practice to enable different sorts of careers and different sorts of lives within academia, but also for academia to properly encompass that diverse community and therefore benefit from it. There was an initial focus on STEM, but then subsequently it is broadened out to a range of, well, the full range of disciplines, and broadened out now into institutional level change. And for those of you who haven't been through an Athena Swan, I think it is one of those brilliant processes that forces you to ask questions about your culture. How do we make decisions here? How are voices included in decision making? How do we think about promotion and what counts for promotion and doesn't? And it has now continued to broaden out, both in terms of including student data, which I think is really important, and it has gone international. So I think initially Australia was one of the places that picked it up, and I spent a fair amount of time in Australia, and it was making a real splash there when I was there more frequently, now in the States and around the world. So actually this move has been really important, not just for physics or astrophysics, but actually for all of us who care about the position of universities as part of communities and as universities that are going to enable a much greater diversity of membership, and that being the source and one of the key sources of the way that we bring about change in knowledge and change in society. So that is really important to us here. And it's been really important to me personally. So Jocelyn, I got to know a few years ago, and I heard her story, and I saw the way she enacted being somebody of that seniority. And I'm delighted Simone is here with us as well today. And one of the things that Simone has really prioritized is a form of compassionate leadership. Compassion being that which has empathy, understanding the other, but also being focused on change. And those two things linked together. And I saw those exemplified in Jocelyn in the way that she has enabled communities to grow and to thrive and to become changed from within and from without. That is exactly what I think we have the opportunities to do in Salford. EDI already runs through everything that we do. Descriptively, we are a pretty diverse community, but our really interesting question, I think, is what are we going to do with that? What changes do we want to bring about because of that? And how do we approach the world in a way that helps that change happen? So, for example, we do wonderful work here on health, but we can do something really quite special and different on the inequalities of health and forms of exclusion that mean that you've got really quite detrimental outcomes for whole groups of society. We're doing great work on creativity and innovation, but again, that can be researched in some ways that ends up closing the doors rather than opening them up and therefore changing the notion of what we're doing. When we think about prosperity, the third of our key themes, this includes things like productivity and business, but actually we have the key questions of how people become engaged with productive activity and therefore benefit from it. So in all of these themes and with environment and sustainability, the answer is not to close down and to look in, but to open up and to look out. And that means all of us actually need to operate in quite different ways. We need the compassion, but we would need to be oriented towards learning and changing ourselves through dialogue with others. And that is actually, it's what we ought to be about as universities, but actually quite hard to do. And therefore, I think we need the sort of culture here that supports that. Part of the reason I am deeply excited about Jocelyn being here, as you can tell, is I think she's an exemplar of not just aspiring to that and the rhetoric of that, but of changing and enabling other people to change and getting the structures and the systems to do that. I'm utterly delighted and very enthusiastic, as you can tell, that we've got Jocelyn with us today. And I hope that wasn't too embarrassing. Probably was, but sorry, it's just the way I am. I think you're going to have a brilliant, brilliant time in this lecture, and I think it will help us all move forward in terms of setting our next agenda. So I'm handing back next because I think Pradeep is going to say a few words. Thank you.
Thank you, Nick. Thank you so much. We are now nearly to our speaker, but I would like to ask Pradeep Pasi, our Associate Pro Vice Chancellor ENDI, to come for a few words.
Thank you, Marina, and thank you, Nick. Can I also say I'm absolutely delighted to be here this afternoon as well to mark International Day of Women and Girls in Science, which is what this event is all about. And add my welcome to you, Jocelyn, as well. Even as a non-scientist, I'm really looking forward to your lecture and your insights. We all know about the underrepresentation of women and girls in science. According to the United Nations, only 1 in 3 researchers globally are women. And we know that stems from embedded and structural biases in society and industry, even here in education. And so you look at areas like computer science, maths, engineering, physics. Still, there is a real absence of women in those areas. And the way that I sort of conceptualize that absence really is lost opportunities and missed talent. And if we continue down this path, the question really is, where does that leave us in society with the big global challenges that we have? We're in kind of, I hate saying this word, but unprecedented times in terms of global conflict, climate change, health inequalities, and so on. And so if a significant proportion of our talent pool is missing from finding the solutions to those things, then where does that leave us? I think in a pretty precarious position globally. So we really need to think about how we open up that talent pool to remove those barriers, to remove those impediments, and really think about how we can sort of seize those opportunities and make sure that talent that is going to enable us to find those solutions is not missing. I could go on and on about that. But our kind of contribution to that here at the University of Salford is really kind of making sure that women are really central to our EDI goals that we want to achieve over the next few years. So we've set some ambitious targets to make sure that our senior leaders within the university more accurately reflect our student population in terms of gender. We want to increase the population of our professoriate to around 50% women. And also we want to increase the number of minoritized ethnic women who are undertaking research, because when you take that intersectional approach, there is a real absence in that space of talent as well. So we're working over the next few years to start removing the barriers, understand what is needed to move forward in those areas, and hopefully make sure that we're contributing to that talent pool that's going to be needed to move society forward. So I'm going to kind of stop there, but I really kind of wanted to welcome Dame Jocelyn Bell Burnell to the university, who will hopefully help us to further look into these issues and provide further inspiration. Thank you, and I'll hand back to Marina.
Thank you, Pradeep. We're now nearly to our speaker, but I would like to ask Denise Rani, our acting dean of the School of Science, Engineering and Environment, to say a few words.
Thank you, Marina. Good afternoon, everyone. I'm not going to say very much because, as Marina keeps saying, we're nearly to our speaker. My role today as acting dean, and I've always said being an acting dean is a bit like pretending, and now I'm pretending and acting on a stage, which I don't usually get to do. So I'm actually living my role with you this afternoon. But I just wanted to say it's an absolute pleasure to see an audience here to listen to our speaker this afternoon. It's great to come together to celebrate this International Day of Women and Girls in Science. And as a colleague who's worked in science, engineering and environment at Salford for a long time, I think this is one of the most exciting speakers I've ever had the opportunity to introduce. Marina is going to tell you a little bit about Jocelyn's biography, but it's super, super impressive. From the early days of her research work, which Nick mentioned was really groundbreaking, to her recent activity around enabling, encouraging and supporting more women to conduct research in physics and to encompass other groups, including refugees, in the utilisation of funding to develop all aspects of research in physics. And as Pradeep said, not wasting talent that is available on the planet. The other part of my role here today is to say thank you, thank you, thank you to Marina for organising this event. Marina arranges something every year to celebrate the International Day of Women and Girls in Science, and I think this year is an absolute perfect example, and not quite culmination, because I'm sure she'll come up with something again next year, but this is a really great occasion. It's lovely, as I said before, to see so many of you here and to hear the presentation we're about to hear nearly in this theatre. So I'm going to hand over to Marina, who's going to do the final stages of our introductions.
Thank you, Denise. I would like now to introduce our guest speaker, Professor Dame Jocelyn Bell Burnell. Professor Bell Burnell is an astrophysicist and astronomer, currently a visiting professor of physics in Oxford University. She has been a Dean of Science in Bath and was for 10 years professor of physics at the Open University. She completed her physics degree at Glasgow University in Scotland and then followed a PhD in radio astronomy at Cambridge. She was involved in the discovery of pulsars, which opened up a new branch of astrophysics. Her supervisor was awarded a Nobel Prize for his work, and she has since been recognized for her contribution in astrophysics. She has been awarded the Oppenheimer Prize, the Michelson Medal, among other medals and awards. She's a fellow of the Royal Society, has been president of the Royal Astronomical Society. She was the first female president of the Institute of Physics. She was always been passionate and promoting public appreciation and understanding of science. She hopes that her presence as a senior woman in science will encourage more women to consider a career in science. Professor Bell Burnell, hand over to you.
Good afternoon, and thank you very much for that kind introduction. And thank you also for the opportunity to be here, even if I brought the rain with me. Under the heading of Women in Astrophysics, I'm going to talk, first of all, about 4 female astronomers: Caroline Herschel, Cecilia Payne-Gaposchkin, Vera Rubin, and Rebecca Elson. I'm then going to review the position of women in physics and astronomy, and finally talk about some data collected by the International Astronomical Union, which is the global body that embraces astronomers in every country, professional astronomers, and the professional astronomical societies in every country. And then I might rant a bit at the end. So, going to start way back, 1750. Germany, a young woman, a girl called Caroline Herschel, is born. She was born into a family of military musicians. Her father and several of her brothers were in the military because they were good musicians, and they were in the military bands, I suppose you call it. She spent much of her life in Britain, although she died in Germany. She actually lived in Bath. Did wonderful work, which I'll describe shortly, finally resulted in a gold medal for her when she was 78. She got elected a member of the Royal Irish Academy at age 87, and she got given a gold medal by the King of Prussia at age 96. Isn't it lucky she lived as long as she did? She and her brother lived in this tiny terrace house in Bath. It's the one behind, there's a motorbike covered with a pale grey cover. So it's very narrow. There's a front door and one window on the ground floor frontage. It's got 4 floors. It goes back quite a lot. Her brother, William, lived here, and she came to join him as his housekeeper. It's now a museum because the pair of them did very good work while they were there. It was here that William discovered the planet Uranus using a telescope in his back garden. And there is a plaque there commemorating it, and also commemorating Caroline, who found several comets. The back garden now backs onto Sainsbury's supermarket car park, well illuminated. But members of the local astronomical society decided to see if it was still possible to see Uranus with Herschel's telescope. It needed 2 people, one person with Herschel's telescope, one person with a very big pair of binoculars, strong binoculars, and a laser pointer. And the guy with the binoculars managed to find Uranus over the car park and its lights, and used the laser pointer to point at it. And given that guidance, the guy with Herschel's old telescope could still see Uranus. There were kings, German kings, Hanoverians on the throne at the time, and Herschel got invited to move nearer to the king, and they went to live in Slough, which is also near Windsor. I'm not sure if the family owned Windsor at that stage, but anyway. Caroline had her own much smaller telescope, and when William was away, she would use it. When William was around, she was his clerical assistant. He would observe with the big telescope. He was observing when stars passed across the wires of his telescope, and he would shout, "Now," and she'd note the time, log the star. And that way they built up a catalogue of stars, which was unrivaled at that stage. William gave Caroline her own telescope because he had to travel every so often. And when he was away, she would use her own small telescope, and with it found a number of comets. She also got given a small salary by the king, so she's technically the first female civil servant in Britain. These are a couple of comets, well, 2 shots of the same comet, to be honest, wonderfully spectacular objects, and Caroline found a number of them. From working with William, she knew the night sky very, very well, and she knew when there was something extra around. And that extra thing, a comet, would also move relative to the constellations, and it might well develop a spectacular tail. So she became an expert on comets and was responsible for discovering 8 or 9 comets, if I remember correctly. As you can see, she lived to a She lived to a grand old age. I don't think I have it displayed, actually. Went back to Germany when William died, and I think wasn't terribly happy there. I think she really rather enjoyed the rather more liberated life in Britain. So she was one of our first outstanding female astronomers. The next woman I want to talk about is called Cecilia Payne-Gaposchkin. She was born Cecilia Payne in 1900, lived Oxfordshire, Buckinghamshire, I'm not quite sure which, went to the USA ultimately. And she was the first person to recognize that stars were made largely of hydrogen. It was part of her PhD thesis. And it was such a revolutionary discovery and so against the conventional wisdom that there was anxiety that she might be failed in her PhD. She played it rather safely by saying, you know, this is counter to all the received wisdom and may be wrong. But actually it wasn't wrong. She was right. She was good at science at school. She went to a school in London, had a very good music teacher there, famous music teacher. And she apparently was quite good at the violin, and he wanted her to become a professional violinist, but she was determined to do science. She got a place at Newnham College, Cambridge. Very few places for women in Cambridge at those days, but she got there. And very early in her career in Oxford, almost by accident, she got a ticket to a big lecture. A lecture describing the results of an occultation that showed that Einstein's theories were probably right. And she was absolutely stunned by this and decided that, yep, she wasn't going to do botany or search for flowers, which is what she'd originally gone up to do. She was going to do astrophysics. And she ended up working a bit with Eddington at the observatory on a project. Now, for my next topic, I'm going to have to, I think, show you a graph, with apologies. They're not that scary, and I think I can talk you through it. As I want to talk about a woman called Vera Rubin. She spent all her life in the United States. She died relatively recently. And she had an uphill battle in her career because she kept getting results, or a result in particular, that defied what was currently accepted as the true picture of the universe. So here comes a graph. We're looking at a galaxy. We're looking at stars in a galaxy. We're looking at what speed those stars are moving, because the galaxy rotates and the stars are going round more or less in circles. And the black curve is what she found. The dashed curve is what we expected. In the inner parts of the galaxy, the stars rotate slowly, getting faster, faster, faster. Don't worry about the bump. And then it tends to level off. And when you get to the edge of the galaxy, it starts dropping, according to the theory. What Vera Rubin and collaborator found that, yeah, this bit's okay, but it doesn't fall. It keeps going on, up, which rather implies she hasn't found the edge of the galaxy. But she knows she's found the edge of the galaxy. She's, reached the end of the visible image. At the edge of the galaxy, you'd expect this curve to drop. For those who are physicists, it should follow Kepler's third law. So it's a dropping curve, something like this. And hers wouldn't drop, which implied she'd not found the edge of the galaxy. Even though she'd reached the edge of the visible galaxy, there clearly was more stuff, and quite a lot of stuff, because to keep things rotating at this speed and not flying off into space, there must be a lot more gravity in that galaxy than anybody had accepted. And it's not material that shines, it's dark material. We now call it dark matter, which is what she had discovered. She had one hell of a time getting this accepted. She'd, send off a paper for publication in an astronomical journal, and the result was so unexpected. Editors would say, get more data, or do this, or do that. So she'd get more data, same result. Get more data, same result. Get more data, same result. Finally, the astronomical community gave in and admitted that she was right. So we now know of lots of these wonderful spiral galaxies. This is a bit what our galaxy would look like if we were outside it. And incidentally, we're not at the center. We're about 2/3 of the way out in our galaxy. So we're not anywhere special in terms of the galaxy. But in amongst all this visible material, there must be dark, solid stuff, particles, something, but dark, that's contributing to the gravity. And this we now know to be in the case in every galaxy we have scrutinized thoroughly enough. We call it dark matter, very creative. It's matter and it doesn't shine, so it's dark matter. It's also now being found in clusters of galaxies. So let me back up just a second. We live in a galaxy. It's called the Milky Way. We don't live in the center of it, folks. We're about 2/3 of the way out from the center. And we know there are many, many other galaxies. As a rough rule of thumb, 100 million stars, 100,000 million stars equals one galaxy. 100,000 million galaxies perhaps equals one universe. That last line is very rough, but just to give you a clue. And sometimes the galaxies themselves come in groups called clusters of galaxies. So this is a picture of part of one of our nearby clusters of galaxies. That's a galaxy, so's that, that. Everything that isn't sort of pinpoint in this image is a galaxy, like our Milky Way, 100,000 million stars. And these galaxies are milling around in the cluster, and we can work out how fast they're moving away from us or towards us. We don't normally see motion across the field of view because we haven't been looking long enough. And if we study at least the speeds into the frame, into the screen, we find these galaxies are moving at quite a lick, and sufficiently fast that you would expect this cluster to sort of dissipate, evaporate, but it hasn't. And this is more evidence for this stuff called dark matter. Not only in the galaxies, but between the galaxies, there's dark stuff providing gravity, which helps keep the cluster together. We got better evidence of this with this particular image. The thing I want to point out to you is a kind of loop of streaks going round, and actually there's a second loop further out as well. These are distorted images of galaxies. Way beyond this group of galaxies, there is something very bright, and the gravity of this group and the non-uniform distribution of the gravity of this group makes the images of that very distant object come out as streaks. And by the separation and by the streakiness, we can work out that there's a lot more gravity in this central thing than is obvious from the light. Again, there is dark matter. This was one of the final pieces of proof that really convinced the astronomical community that there's a lot of dark material in our universe that we haven't yet got a full grip on. So at that point, I'm going to change tack slightly and introduce you to some female astronomers. And the first one, no longer with us, was Canadian, born in Canada in 1960, died of cancer here 1999. She studied the evolution of stars, but she was also a poet and wrote some lovely poetry with astronomical theme. And I'm going to read you one of her poems. Let There Always Be Light, or Searching for Dark Matter, the stuff I've just been talking about, by Rebecca Elson. For this we go out dark night searching, for the dimmest stars, for signs of unseen things to weigh us down, to stop the universe from rushing on and on into its own beyond, till it exhausts itself and lies down cold, its last star going out. Whatever they turn out to be, let there be swarms of them, enough for immortality. Always a star where we can warm ourselves. Let there be enough to bring it back from its own edges, to bring us all so close that we ignite the bright spark of resurrection. So that was Rebecca Elson. Having talked a bit about a few women astronomers, I now want to look more widely, worldwidely, about women in astronomy today. And the story starts in Denmark, where there's a married couple who are both astronomers. He has no trouble getting good jobs in Denmark. She has huge trouble. He knows she's a very good astronomer, maybe even better than he is. Is it her gender that's preventing her from getting a good professorial post or something in Denmark? He's secretary of an international astronomical body called the International Astronomical Union. And he realizes that as secretary of this body, he has access to data that will tell him whether Denmark is more sexist, less sexist than other countries in the world. This data has been accumulated for quite a few years, and I'm now going to show you some tables of data over a number of years, showing what fraction of astronomers in different countries are female. And we start way back in 2005. I quizzed the database. I limited myself to countries with more than 50 members so that the root N error wouldn't be too bad. And then I have listed them in order of percentage of females. And at that time, the best country in the world was Argentina, with 35% of its membership female. France was good, Italy good, Brazil good, Ukraine quite good, Russia. Yeah, okay, I can understand that. Spain, Mexico, Finland, Sweden. The world average was 13% female. And then here's the UK, 2005, 10%. Netherlands are worse, India, perhaps we can guess. Japan, we can guess. In Russia, following the world wars, they lost a lot of their men in the war. Women had to go out to work, and the state had to provide nurseries to enable women to work. So I think that's why Russia is reasonably high up this list. The Latin countries seem to do pretty well. Latin and South America. So France, Italy, Spain, Mexico. Finland I wouldn't describe as Latin, but we got down to 13%. Sweden, much the same. UK, rather dismal. But that was 2005. Maybe it gets better. I haven't said which country this is. This will be a year or two later. Argentina's very high. France, very high. Italy, very high. Brazil. Ukraine, way up there. There's Russia. Spain, Mexico. France, Sweden. World average, under 13% female, which is not very, very encouraging. And where's the UK? There we are, 10%. Way under the world average. Not good. But, well, we're better than Japan, Israel, India, Korea, Germany, Switzerland, Czech, Chile. That's slightly surprising. There's Netherlands. Yeah, well, not delightful. Moving on. I think we're now about 2016 for this one. Same kind of table, same kind of South America, Southern Europe kind of pattern, Russia doing well. Here's the best English-speaking country, 15%. It's at the world average. UK 12%, USA 12%, English-speaking Canada 12%. We're not doing very well. Nordic countries not doing terribly well. India and Japan, yeah, we know what's going on there. World average, 15%. 2018, this is getting closer. World average is now 17%. And again, Europe, South America, Russia doing well. Australia's just under the world average. Canada's even more under the world average. USA, UK is sinking. Not good. India and Japan down the bottom. (2020). This is the last but one of these. World average now 19%. Same old pattern. Italy, France, South America, Russia. Netherlands going up quite steadily. Australia, USA, Canada, and UK dropping. Only Japan is worse than us of all the major countries. Finally, 2023. Italy, France, yep. Australia's going up the world. Spain, Brazil, Russia. Netherlands is rising steadily. India, South Korea, USA, UK, not doing very well. So, what's going on? Well, I've discovered a number of flaws in this game. And one is that it requires the professional body for astronomers in each country to forward names to the international body. And the UK body has had a change of chief executive, and the new chief executive didn't know he was meant to do this. So it hasn't been done for a number of years. So that's probably partly why we're sinking. But a little bit ominous if that's the kind of thing the chief executive doesn't know he's meant to do. You wonder how many other gender issues he doesn't know he's meant to do. This has also been done throughout on a binary basis. You're male or you're female. No other selection possible. And that has irritated a number of people. And in March of this last year, they set up a commission to look at the issue of gender. And They got, oops, wrong. They got a more liberal definition of gender. It's meant to be a spectrum, and you position yourself on the spectrum. But look at the order in which the spectrum is laid out. Alphabetical? No. Okay, it's a spectrum, so you can't change the order, but you could at least start with the female because F comes before M. So I yelled at them, and they have turned it the other way up. But this happens all too often. If you had to fill out a form which asked which sex or gender you were, we're a bit variable in how we use those terms, and there's maybe 3 boxes, M, F, and prefer not to say. You'll have seen those. Why does M come before F? This is unconscious bias writ large. I now have an enjoyable game. I get sent one of these questionnaires about feminism and gender issues. And sure enough, there's something that goes M, F, other, prefer not to say. And I send it back and I say, your survey is showing unconscious bias. I am not going to complete it. You too can join in this game. Wait a few days and an email will come back. Dear Professor Burnell, we are desperately anxious not to be, discriminating, blah, 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 blah. We do this, that, and the other. We've looked very hard at our document. We can't see the unconscious bias. Could you tell us where it is, please? And you can tell. But it's still happening all too often. So please be stroppy and nuisance like I am, and we'll get the world put slightly better. A little bit about gender issues in the UK. There's a website called Let Toys Be Toys. They've done word clouds for the words used to advertise boys' toys and girls' toys. Do you need telling which is which? Yeah. Do you wonder that we don't get women engineers, women scientists, if that's what's being thrown at little girls? So Let Toys Be Toys is a campaign for more gender neutral advertising and marketing of toys. Just a few slides now about what's been going on in the UK as I have seen it. I'm now 80, so I've seen quite a bit of this, maybe slightly more than most people in the room. I did a physics degree. I was the only female in the class. It was the tradition in Glasgow that when a woman entered the lecture theatre, everybody whistled and stamped and banged their desks. How to greet women as they enter the lecture theatre. But by and large, as a young woman, I thought the battles had been fought. And I have learned otherwise. I think that's why you see more older women than younger women are ardent feminists. We now regularly collect data. How many women, how many men are there at each level, particularly in academia? It shows that women are in a minority. The minority gets smaller as you go up the ranks. It also shows that women progress more slowly than the men. And in my area, in science at least, it showed that women were putting in fewer grant applications, were less willing to apply for jobs. In other words, weren't putting themselves out there to the same extent as their male colleagues. So the first attempt was fix the women, make women braver, more willing to put in grant applications, more willing to apply for promotion, apply for jobs. And they set up special training courses for women to make them braver. There's an assumption that the fault lies with the women. And the way that academic society and academic science in particular is run is fine. No problems there. I think we've now learned that maybe it's not that simple, and that there are issues all round. Another thing they did was returner fellowships for women coming back, particularly from maternity leave or some other career break. And things that were maybe open to women only. And some of the first people who got these returner fellowships found they were being greeted by some of the less gentlemanly men in their department saying, you only got that funding because you're a woman. You're not up to the academic standard of the rest of us. You should leave. So the next step was to increasingly make these kinds of funding open to both male and female returners. And then the funding agencies had a further think and reckoned that whilst it was very nice to help individual women, it might not be changing things, changing academic society as much as they thought it was. And they began to look at what we call institutional change, making a place fairer for everybody, not just for women. So some examples of institutional change, structures that might be discriminating, possible biases in recruitment, retention, a lack of awareness of different management styles. She's not doing it as a gung-ho male, therefore she's not a good manager. She hasn't sacked anybody yet. And also unconscious bias, which I think is in all of us. And I've already talked about the male-female boxes with M coming before F. We're in a situation now where things are changing quite fast. Looking around Oxford, I would say some people are feeling it's changing too fast. But most of those some people are older generation, it has to be said. Particularly in the US, in my subject, there's been exposure of what we know of as serial harassers. I'm an astronomer, observing at a telescope at night. It could be part of your job. Sometimes men come along to assist the young women who are observing at telescopes, and assistance isn't quite what they had in mind. So 1 or 2 people have been sacked. Will there be a pushback? Is this going too fast? I don't know. I don't see much of a pushback yet, but we'll see. So in conclusion, for women, make a joke of it. There's not much else you can do sometimes, but it does cost. But I have learned that stories are very powerful. So telling stories is important. For all of us, good management is vital. And not everybody who thinks they're a good manager is a good manager. So, yeah. But also don't expect women to conform to the male norm. They are not we men or she males. Allow the differences. We need more scientists. We need more engineers. We are still, I think, not making full use of our females. Girls can do physics brilliantly. I know that girls are more likely to do physics in a single-sex environment, so maybe we have to consider that for some of the schooling. But the global data I've shown you from the IAU shows that women's brains are not the limiting issue. And on that cheerful note, I will stop. Thank you for your interest and your attention.
Thank you so much. I think we are ready to accept some questions. Yeah.
Hello, good afternoon. So I'm the mum of a 20-year-old female scientist who's doing an engineering degree apprenticeship at Warwick. And her EPQ during her A-levels was on how structural engineering can impact space. and she would love to work on the mission to Mars. So if you were to look back to your 20-year-old self, what advice would you give her?
I think hang in there is the most important one. It can be uncomfortable, it can be discriminatory, but a certain amount of stubbornness is required. And if you know what you want to do, that's great. If you don't know what you want to do, there's a risk that you decide, well, I'll go do that because it seems more comfortable. But hanging in there, I think, is the really important thing. And then as you get beyond the stage of being, you know, the newest, youngest female in the place, look out for other younger women, create networks for the women, particularly in subjects where there are very, very few women. Some networking is quite important.
Hi, I just want to ask, I love to talk, how have you dealt with imposter syndrome throughout your career as a scientist?
It was particularly bad when I was a graduate student. Turning up from Glasgow to Cambridge was quite a transition. And Cambridge was full of young men, a bit like Boris. I know he went to Oxford, but a bit like Boris, walking along King's Parade, talking in a very loud voice about the philosophy of so-and-so, knowing damn all about it. But I sort of got taken in by that. So moving to Cambridge was really very scary. And I was quite sure they'd made a mistake admitting me. They were going to discover their mistake and throw me out. So I developed a policy which I would recommend to anybody who thinks they've made a mistake admitting me, they're going to throw me out. And that is to say, until they throw me out, I will work my very hardest, so that when they throw me out, I won't have a guilty conscience. I'll know I've done my best. And they probably won't throw you out.
Go for it, have a go. Oh, okay, that's working. One of the many critiques I hear, like responses I hear to what is lack of women in science is that they choose to do other subjects. What would your response to that be if someone's, well, I'm not saying that, I think that, but I wonder what your response would be.
Yeah. I certainly found as a young woman interested in physics that there was a lot of, are you sure you want to do that kind of thing? How can you bear to do physics? There was a fairly steady drip of that all the way through my school years. And also at university, particularly when they discovered I was the only female in the physics honors class, you know, are you sure you want to do physics? I was lucky in that I knew I wanted to be an astronomer, an astrophysicist, and therefore I had to get a physics degree. If I hadn't had that, I might well have quit and done something else, or just quit my degree altogether. So I was lucky in that I knew what I wanted to do, and I knew the route to get there. It was just a case then of struggling through it. You're not on. Your microphone's not on.
Is it on? Yep, works. Thank you so much for that inspiring talk. I just want to ask about the data you presented.
Yeah.
And do you know why, or do you have an idea why, for example, Latin American countries, Italy, France, Turkey, usually that's not just for women in astronomy, but in engineering science in general. We found that the UK, most of the time, it's at the lower of the ranks.
Yeah.
Why do you think that Latin American countries that are much poorer than the USA, much poorer than the UK, much poorer than Germany, do better with the having more women in engineering and science and astronomy?
Well, one possibility is that in those countries there are a lot of poor people, in particular poor women, who are only too happy to come into your house, wash the dishes, look after the kid, clean the house, while you go be an astronomer. So I think in part it's to do with the way society is structured in the different countries. And some of those countries that have a high-ish proportion of female astronomers are countries where I think there's a great disparity in wealth. There's very rich and very poor, and I think that's part of it. So that's a very practical issue, but it's the kind of practical issue that can wreck a woman's career.
Hello? Yeah. Okay. I was going to ask a very similar question, but kind of from the opposite angle, that I noticed that, for example, the Netherlands had kind of moved up. Do you know if there's anything positive that they did that perhaps we could emulate?
Yes, we could emulate. The Netherlands has had a campaign. They have been allowed to advertise women-only posts in technical and scientific areas, for instance. I think they have to get special permission to do it, but they can get permission to do it in order to rectify the gender balance in that institution or university or whatever. And that has made a difference.
Do you think we could emulate something similar here?
Her further comment was, do you think we could emulate something similar here? Yeah, of course we could if I put our minds to it. Government actually seems a long way from doing anything like that, but we could. Yeah.
Okay. First of all, thank you so much for this inspiring talk and for coming to our university today. My question is more of a personal side. What motivated you in the hardest of times? Because life is a roller coaster. So thank you.
I was very lucky in that I decided at about age 12 what I wanted to be. And in spite of being that young, in a sense, hit the right thing. And if you know what you want to be, that helps shape decisions. You know, I could quit this physics degree because it's awful, but I want to be an astronomer, so I've got to get this degree, so I've got to stick these next few years, kind of balance. So I was lucky. I was, to say, I think about 12 when I decided I wanted to be an astronomer. Indeed, it was quite a striking moment. For those of you who've done some physics, you may have learnt about motion in a circle, centripetal force, centrifugal force. We were learning about this in physics classes at school, and I'm reading a book that my father's brought home from the library by Fred Hoyle, and he's talking about the rotation of galaxies and centripetal force and centrifugal force. I can be an astronomer. Oh, no, I can't. They work at night. I need my sleep. There are other kinds of astronomy, like radio, that you do in the daytime. I'll be a radio astronomer. So from about my mid-teens, I knew what I wanted to do, and that helped see me through. Now, not many people, I think, know that early and get to do that. So I'm not quite sure what the solution is for people more generally, except expose your teenage kids to all sorts of things and maybe they'll latch onto something.
I was just wondering how you felt and what you thought when your supervisor was awarded the Nobel Prize as opposed to you for your discovery of pulsars.
It was a memorable day. I was working in X-ray astronomy at that stage, and to do X-ray astronomy, you get your kit on a satellite way above the Earth's atmosphere. And our satellite had launched that morning about 9 o'clock. And about midday, a colleague, a bit of a stirrer of a colleague, came rushing into my office. Have you heard the news? Have you heard the news? And I thought, the satellite's gone in the drink. And it wasn't. It was the announcement of the Nobel Prize. I was actually very, very pleased because I knew that that was the first time that the physics prize had gone to an astronomer. There is no astronomy Nobel Prize. And I knew this created a precedent and other astronomers would get it in due course. And I'm absolutely right about that. So actually I was pleased, and my colleague was slightly discombobulated, I think we say. However, a colleague of mine from the USA got the Nobel Prize for pulsar work a few years later. And being a nice colleague of mine, he invited me along to Stockholm as one of his guests. It made the Nobel Secretariat very twitchy. I think they thought we might be staging a demonstration or something. We weren't. We all behaved perfectly. And I got to see the Nobel Prize week. Be careful about wishing to win a Nobel Prize. It is very, very hard work that week in Stockholm. Much better to go along as a guest. That's fun.
You mentioned it was when you were having physics lessons at school that it kind of triggered your thoughts. Was it to do with the actual physics teacher you had? Were they an inspiring teacher? Well, I presume they were male, but I don't.
Yeah, I was at a girls' boarding school and we had trouble getting science teachers. Our maths classes were at 5 o'clock at night from somebody who taught at the local grammar school and then came in to teach us. This was A-level maths. Chemistry was abominable. I remember asking the chemistry teacher, what's all that periodic table up on the wall? And why is it the shape it is, the layout it is? God made it so. Our physics teacher had come out of retirement a second time to teach us, and he was a brilliant teacher. Very, very clear. And when he realized I was interested in physics, he said something that wouldn't be legal today. This is a boarding school. If you want to, come into the physics lab at night and play with the equipment. So I did. I decided I was going to make a very large map of the magnetic field of a magnet. So I went to the drawer where the magnets are, pulled out the drawer, got a magnet, put it on the bench, closed the drawer, got a big sheet of paper, blah, 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 blah. Didn't finish it in one night. Came back the next night, positioned myself, same place, same bar magnet. Couldn't line up with the work I'd done the night before. If you want to study magnetism, move away from the drawer where the magnets are kept.
Hello. Professor Burnell, thank you for coming. It was an inspiring talk. And I just wanted to ask, looking at some of the data, certain countries, because I'm ethnically like Pakistani, like understand certain social structures may be affecting certain things. But in the countries like Europe and the UK, so I'm all like in agreement for there should be equal opportunities because everybody should follow what they enjoy and what they'd like to do. And it really spoke to me, the conclusions that you put, that, you know, don't make them we men or like that, because let them, you know, do it in the way that's natural for them, like personality-wise, not just gender-wise. But having heard this since I've been like a boy, like we see, you know, women's rights, what is it that hasn't changed fundamentally in your vast experience that would like facilitate, like, you know, just it not being an issue that, okay, if someone wants to do something, they can do it. And if they don't want to do it, then they don't have to do it. Like, what is it fundamentally that it for so long hasn't changed? That means it's difficult for a talent to be educated or...
Has that changed?
No.
A bit. It's not quite as blatant. But this is dealing with babies, gendering small children. That's what a lot of the women actually have to fight against. I'm sure there are things men have to fight against, men and boys as well. Maybe a macho culture. But this is pretty shocking.
Yeah, it's on. I was going to say that obviously when people read into your background and when we research you, one of the biggest things that always comes up is the pulsar discovery. I was going to ask you what in your career what was the most exciting thing that you found out or discovered, or would it be pulsars, or is it something that came later in your career? What would you say was your most exciting day in physics?
I think it probably has to be the pulsars, but a very close second comes when I worked in X-ray astronomy. Husband had moved job. I got, strictly speaking, a role as a technician in part of University College London, but in one of its outposts set in the Surrey Hills, where there's this space science laboratory. And it didn't really matter there that I was a technician. It mattered when I went up to UCL in Gower Street, because I couldn't use the library without a letter from the prof. But back, you know, at the lab in the country, it really didn't matter. And that particular satellite was hugely successful. I worked very hard to maximize the output from our bit of that satellite, and it really was very, very, very successful. And one of the things we very rapidly learned is that the X-ray sky is not steady. There are things that give steady, you know, stars that give steady X-rays, but there are also what we call transients that flare up and die away again. And this satellite, our bit of the satellite, kept catching these transients as they flared. Usually on a Friday afternoon, preferably the Friday afternoon of a bank holiday weekend. And I have to find somebody to analyze this data quickly, because it's very, very newsworthy and we need to get a telegram out about it. So although I was on the technical staff and strictly speaking in a service role, I was actually in a key role with all the data coming through me and then out to the people who had requested it. And it was hugely exciting and really kept us jumping for about 5 years.
Hello. I just wanted to ask a couple of questions, but I think the most important one for me is what's the view from Africa, especially as regards women in not just astronomy, but science in general. Yeah. And as a bit of a follow-up, are we seeing a widening of the gender pay gap, or is it getting closer, especially with more involvement and more participation?
Well, you won't need telling that Africa's a big place. There's a very interesting set of higher mathematics schools, name temporarily forgotten, it will come back to me, with schools in a number of countries. There's been one just south of Cape Town for a very long time. There's one in Ghana, AIMS, African Institute of Mathematical Studies, set up by Neil Turrock, who's now in Edinburgh University. And these aim to provide advanced mathematical education for talented local people. And they do fantastic work, typically training people up to about master's level, maybe PhD, but certainly master's. And the one in Ghana that I visited recently is also working with girls at what we would call sixth form level, has got together a group of girls who are good at maths from various schools, and pulls them in, you know, one evening a week for some extra activities and tutorials and things. That kind of thing makes such a difference in those sorts of countries. It's a fairly fragile arrangement. In some countries, they've had to close. Other countries, they've opened up and it's run very, very well. It's very variable. But AIMS, African Institute of Mathematical Studies, I think is a prototype that many other subjects could imitate if they so wished.
If there's no hand gone up, I might take, oh, is there one?
Hi. Thank you, Professor Burnell, for that amazing talk where you married the science with the broader messages of things not being quite well. yet. And I'm one of those older women who has a lot of experiences accrued and who indeed in my 20s thought it was all fine and feminism had done its work and everything would be perfect and equal for me. And of course now I think very differently. I'm in the very privileged position of being in a leadership role in the university and now in this one in Salford since just a week. And I'm very aware of the extreme importance of systemic measures, of not leaving it to individual women to change the world around them for them, because it's impossible. Of course, we need the grassroots experiences and activism as well. But if we don't tackle it structurally, systemically, I think we just won't see the progress that we need to see. So what would you say university leaders or leaders anywhere in systems that really need to change should do to really get some things going? Because we can't keep moving at the pace we're moving at. We need to see some real progress.
I think the Athena Swan scheme has stimulated quite a lot of movement because data shows where you are, what's going on actually. I know that the Athena Swan form filling is quite a burden. Turns out, that department's data, that faculty's database is not compatible with that faculty's database. And so pulling together the data is a real nightmare. But those are things that probably ought to be fixed anyway, so that senior management can see what's going on. If you can get something like recognition from Athena Swan, I would say that is recognized nationally and increasingly recognized internationally, because there are other schemes. And it doesn't just apply to science, it applies to arts. Where are the men in the arts field? And so on. So it's quite important. Its weakness is it assumes binary. And I don't quite know how we move beyond that, to be honest. But at least it's doing something.
Hi. So I read about how in your earlier life, only like 3 girls, was it, were allowed to study science at your school, and most of the others did sewing and stuff like that. I'm in my final year, there's 4 girls. So my question I want to ask was, how do you deal being surrounded by men quite a lot and feeling like you have to work harder to have your voice heard by the males in your class?
There's a limit to what you can change as a single female, or one of just 2 or 3 female. You have to do your best work. That's the first thing. You're there for academic reasons, and if you can show the lads and the lecturer that you're at least competent and maybe even good at the subject, that I think is probably the first step. Of course, it is more difficult if there are very few of you, and if you're the only one, like I was in the final 2 years of physics, you don't have anybody to work with. So it's quite hard work. But doing good work, I think, has to be the first criterion for anybody in a minority. If you don't do good work, you are inadvertently damning your gender, cohort, whatever. So do the best work you can, the best academic work you can, I think has to be a very high priority. How you manage to do that is another issue. It a little bit depends on what kind of socializing there is amongst your year group. Sometimes minorities have to work on their own. It's hard work, but in the long run, that will actually do you no harm. You have to work things out for yourself. You get a much better understanding of it than if somebody says, oh, it's, F equals MA. You just write down F equals MA and maybe not understand it fully. But it's tough. I will accept it's tough. But you will get yourself a much better academic training than if you've been able to swan along with a load of friends and helping each other and maybe not understanding it to the same depth. Sad message, I'm sorry, but...
Going to be the last question.
Thank you very much for that very inspiring lecture, Professor. You briefly alluded to pushback. Discrimination obviously is much wider than gender.
Yes.
And when pushback does happen, the most vulnerable get affected. And I think pushback can be very subtle.
Yes.
Do you think we should plan for it now? And what can we do to make sure that that doesn't happen? And what can we do to recognize it when it does happen?
It's very helpful if you can have a peer and afterwards say, I felt his comment was sexist or outrageous or whatever. Did you hear what he said? What did you think? So if you've got somebody, a kindred spirit, to discuss and share experiences with, that's a huge help. But you don't always, as I didn't. And so you do your best analysis yourself, and you carry on doing your best, day in and day out. For several years at a stretch to get a degree, or a job, or whatever we're talking about. As you get more senior, you're more on a par with your head of group, head of department, and you can go to them and say, I think there's sexism in our group, department, blah, 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 blah. And some of them won't know what the hell you're talking about, but some of them will listen. And you may also find within your group somebody who is a bit more alert to some of these issues. It might well be a man, not a woman. And you can, say to them, I thought Joe's reaction was a bit fierce. What did you think? Sound them out gently to begin with, but you may well find allies there. And increasingly so, more and more of the men I work with are as alert as I am to these kinds of issues. So there's more support, people to provide support out there. Just got to find them. Thank you.
Thanks again for a wonderful talk. I would like to thank everybody for being here today. I hope you enjoyed this event. Please help yourself outside. There will be lunch and there will be some more moments for further discussion if you wish. Thank you.
Thank you very much. Thank you.